Good morning, Caroline O'Brien from Kubos Semiconductors. Pleasure to be here today, and the controversy continues because I'm basically presenting today what Kubos has been working on, which is cubic gallium nitride. We're a compatible technology with existing MOCVD and a scalable technology, and we're consistent with a GaN on silicon process, which I'll explain to you as I go forward. So just a little bit about Kubos. We're a Cambridge University spin-out, and we operate a fabless model, so we outsource all of our manufacture and production for our LEDs today. We're a platform technology, and this was touched on a little bit yesterday about microLEDs and really the other applications that we might be able to go into in the future. But initially, we're focused on solving the red microLED problem for displays and AR/VR specifically. So you may have heard of cubic GaN before. It's been written about in papers for many years. But nobody until Kubos has been able to make it in a scalable and industry-compatible way. And what we've demonstrated, and what I'll show to you today, is that we've eliminated the basic physics and the challenges that were shared with us yesterday about hexagonal GaN in the longer wavelengths and being more efficient. So the markets that we're addressing is, first of all, displays. We can also solve the green gap in lighting. And in the future, as our stack matures, then we will address also communications. In terms of why we think we're a good solution for communications, cubic GaN actually has shorter carrier lifetimes over hexagonal GaN, which enables us to potentially switch faster. We've measured these lifetimes, and we believe that we could be 2 to 3 times faster than existing hexagonal GaN. So really exciting in communications. But that's all I'll say about that today, and focus on the red microLED issue. So what is cubic GaN? Cubic GaN is the metastable state of hexagonal GaN. So we force it into a cubic crystal structure. This requires certain temperatures and pressures. We also do it in a scalable way. So today we're on 150 millimeter wafers, but within the next 12 months, we'll be going to 200 millimeter, and we believe we can go beyond that. But 200 millimeters is probably a good cost point to enter the market. So we use standard MOCVD growth reactors, and this is borne out in our fabless model, that we use reactors that one day could be growing hexagonal GaN or other materials, and then the next day that we're growing our cubic GaN on those materials. Interestingly, we are a GaN on silicon technology, but whereas today GaN is on 111 silicon, we're actually on 001 silicon. So that offers future potential as well. Not sapphire, I'm afraid. In terms of showing what we've done already, you can see here that we've got a green LED. This is 100 micron meso size, but it shows that we can produce cubic GaN LEDs with good light output. And we believe it's the first demo that's been done for cubic GaN in the world. So just looking at some of the basics, and this is work that we completed around about 2 years ago, but I want to recap on it for those of you not familiar with cubic GaN. So effectively, one of the questions we get asked is, can you grow 100% cubic GaN? And you can see, you can see from here that we can grow 100% cubic GaN, because on the top, you can see there we've got the hexagonal peak and the cubic peak. And in the material below, you can see that hexagonal peak has been eliminated. So we can grow 100% cubic GaN. And as you can see from here, we can grow also on large wafer sizes. In terms of processing, again, standard processing, which is really important, particularly for some of the techniques that we saw yesterday for improving efficiency. Those can also be applied to cubic gallium nitride. So whilst we're developing a revolutionary material, in terms of introduction to the market, it's coming in a very evolutionary way, where existing and good techniques that have been applied to hexagonal GaN can also be applied to cubic GaN. That's in the processing, but it's also in the stack development, and we've used hexagonal GaN techniques to improve our LED stacks as well. So there's some really good opportunity there for people who are looking to move from hexagonal GaN to cubic GaN. So this slide shows effectively that we can do the standard